So in this problem, what we have is we have a ball of mass 0.275 kilograms, and it's spun around vertically. So the circle mass described is on the ball described is on the vertical axis, and the length of the string that you're putting the mass on is 0.85 meters. So the first question to ask is, okay, what are the forces acting on this little ball? So first, because we're spinning around vertically, you will always have a gravitational force. This gravitational force always points downwards. It's just the weight of the ball. And other than that, we have the tension of the string, which is keeping the ball in a circular motion, and this string tension will always point towards the center of the circle that the ball is describing. So now what we can do is we consider two specific cases. First, we can look at, okay, what happens when the ball is at the top of the circular trajectory. So here we have a force diagram. In this force diagram, we have that the string tension points downwards because we're at the top of the circle, and the weight of the ball also points downwards. It always does, this gravitational force. Then they ask, okay, if the ball is moving with a speed of 5.2 meters per second at the top, then what is the tension of the string? In order to find the tension of the string, all we need to do is write out the force equation. So we have mv squared over L is the standard circular motion force plus T plus mg. So they add because they point in the same direction. For here, you just refer to solve for T to replace the given values by the problem and find 6.05 newtons. And now let's consider what happens when the ball is at the bottom. So now when the ball is at the bottom, we have the weight of the ball goes downwards as it has to, and the tension of the string goes up, because it's trying to pull the ball up to keep going in a circle. So now we're told the string breaks at a tension of 22.5 newtons. How fast can the ball go at the bottom before the string breaks? Now we do the same thing we did in the previous case for the top. We just write out this equation, and now note that it's T minus mg, because at the bottom they point in opposite directions. And doing some basic algebra, we solve for b. Get this equation, square root L over m T minus mg, and we straightforward to replace the values. Then you obtain 7.82 meters per second. So that's the speed right before the string breaks.